Solar was the past, and it's also the future. A solar panel is sophisticated. It's the magic that literally creates sparks out of nothing. Commercial large-scale solar panels have been evolving. When evaluating the quality of any panel, we only need to find one key parameter. It is the efficiency, a percentage number typical from 10 to 23. This number shows you the 1,000 watts power per square meter that the panel can supply. Technically, a solar panel is a current source, with a varying output current and a relatively fixed output voltage. To get the best power, the panel should be leveled no higher than 60 degrees, ideally perpendicular to the sun ray. 20 to 45 degrees is my recommendation for a fixed panel installation. To squeeze the most juice out of the sun, you want to force the panel to operate at its optimal point. Power equals current times voltage. It's a third grader's multiplication question. As mentioned already, the ideal output voltage is fixed, but this voltage drifts slightly under different temperatures. The solar panel can be used directly, but with a controller or a converter in between, the panel's power can be optimized and it's generally more safe. To get the best juice from the solar, a battery is used as a buffer or energy bank. For example, if you power a 10 watts motor with a 20 watt solar panel, the excessive 10 watts power will be wasted during high sun. A battery in that case would store the extra 10 watts for later use, and the potential power of the panel is maximized. The wattage of your panel and the size of your battery depend on your application and is beyond the scope of this video. Similar solar panels can be wired together to form a new single solar array. There are two approaches to this problem: series and parallel. For series, voltage doubles while current stays the same. This is ideal for minimizing wiring power loss. In other words, you can use thinner and cheaper wiring. For parallel connection, high current means expensive and thick wiring. This is only acceptable if the solar panels are very close to the controller. For the majority, series connection is recommended. The output voltage from a solar panel is not regulated, meaning it's not fixed. A fixed regulated voltage is critical for a majority of applications, especially for charging a battery. Since solar voltage is direct current or DC, we have two main DC to DC converters, boost and buck. The boost steps up the solar voltage to a higher fixed voltage level. The buck steps down to a fixed lowered voltage level. It depends, but a buck converter is generally more ideal because we prefer higher solar voltage as mentioned previously. For a majority of your personal needs, a cheap $10 buck converter from China is all that you need to charge your battery because most battery types can be charged with a fixed maximum voltage. To get all the juice from the solar panel, you need a MPPT controller. A buck converter is not the same as a MPPT controller, but for a majority of the MPPT controllers, they are built using the buck DC-DC topography. The buck converter regulates its output voltage. The MPPT controller regulates both the input and output voltages. As mentioned, to get the maximum power from a solar panel, you need to maintain the solar panel's voltage at a relatively fixed voltage. MPPT voltage can be found automatically by the controller or adjusted manually via a potentiometer. That is all. To sum up, I will give you an example. For a 5-volt solar panel, its open voltage could be as high as 6 volts. A MPPT's job is not only to output a fixed 4.2 volts for charging a lithium battery, but also to maintain the input voltage at exactly 5 volts.